Okay, this is a question from May June 2023 and paper is 5-1. Find the number of ways in which a committee of 6 people can be chosen from 6 men and 8 women if it may include 3 men and 3 women necessary. So total number of peoples are 5. Find the number of ways in which 6 and 8. So you can write total number of peoples are 6 plus 8. 6 plus 6 is 12. 12 plus 2 is 14. So total 14 peoples are there, out of which I have to choose 6 people. 6 people should be chosen, and there is a restriction for these 6 peoples that it must include 3 men and 3 women. So man and woman. Total men are 6. Total women are also 6. 8. Total women are 8. And there is a minimum restriction for a man to be chosen 3. So you have to choose 3 men at least. So you can write 6C 3. Minimum condition for the women to be chosen, that would be 8C 3. So you can multiply these combinations together just like 6C3 times by 8C3. That will become 1120. That is the number of ways through which you can choose the committee. There is a word find the number of ways in which a committee can be chosen. Whenever the word chosen, selection, ways, these are used, these types of word indicate that you have to use combinations, NCR, not NPR. So chosen, selection, all these words indicate that you have to choose the word, you have to choose the combination. So in this way you can arrange these peoples. Paper suggests that a different committee of 6 people is to be chosen from 6 men and 8 women. 3 of the 6 men are brother. Find the number of ways in which the committee can be chosen if there is no restriction on the number of men and women, but it may include that no more than 2 of the brothers can be chosen. Okay, here you have to choose again 6 positions. So 6 people should be there. 1, 2, 3, 4, 5, 6. 6 people should be chosen. Any combination could be possible, but the restriction is that no more than 2 of the brothers. So you can solve in a way just like combinations or combinations without any restriction. It means that you can choose any of the combination, means maybe you can choose 3 of the brothers. There is no restriction. So total peoples are 14. So that would be read as 14C 6. 6 people should be chosen. Maybe here is brother, here is brother, here is brother, and these 3 position may be filled by anywhere. It's not a necessary like there should be 2 brothers. So this is the combination without any restriction. That would be treated as 14C 6. That is coming as 3003, just like marked as equation number 1. Now you will create a combination with restriction. With restriction suggests that all 3 brothers can be taken. For the second scenario I am taking 1, 2, 3, 4, 5, 6. Here is brother, and here is brother. It means that from the man I am taking these 3 brothers together. So it means that out of 14, 3 brothers are already taken. So remaining one would be 11C 3, 1, 2, 3. So other 3 position can be filled by from the 14 one because 3 brothers are already selected, times by brothers can be swapped. Maybe this one comes here, this one again comes here. These are identical, so you can write 3C3. Once you solve it, you will get 1120. Now the required combination becomes just like marked as equation 2. So in order to get the required result, you will write required arrangements are suggest that no more than 2 of the brothers should be taken. So you will write total minus when all these 3 brothers are taking. So total required arrangement could be written as required arrangement when no more than 2 brothers selected. So that could be written as total minus when 3 brothers selected. So totals are equation 1 3003 minus 1120 when 3 brothers are selected. Once you take away these quantities, you are able to get 2838. That will be the answer for that part. So जब भी आपने इस तरह का सिनेरियो आपके पास आए तो सबसे पहले आप देख लें कि टोटल नंबर ऑफ अरेंजमेंट्स कितनी है विदाउट एनी रिस्ट्रिक्शन. सो दे आर 14C6 that are 3003. And second scenario, you just select all these 3 brothers, that is coming as 11C3 times by 3C3 because आपने 14 में से 3 brothers already select कर लिए हैं. So 14 minus 3 becomes 11 and remaining 3 position may be filled by anyone. So 11C3 times by inside the big box there are 3 brothers, so they are identical 3C3. They may be position may be swapped between these brothers 1120. आपने चूज़ करना था कि 2 brothers no more than 2 brothers should be selected. So total minus 3 brothers are selected. जो इसके ऑपोजिशन में ऑपोजिट इसकी स्टेटमेंट है, जब टोटल से माइनस करोगे यू आर एबल टू गेट 2838. Okay, we can also do that question. Question number 3. Find the total number of arrangement of the letters in the word COCOONED. Total number of arrangements. Okay, so total number of arrangements and no more restriction over here. So 1 2 3 4 5 6 7 8. 8 factorial over repeating letters. O is repeating thrice, C is repeating twice, and N is 1 times, D is also 1 times, and E is also 1 times. So 8 factorial dividing by the repeating numbers. C is repeating twice, so 2 factorial times by 3 factorial, the letter that is repeated as O and the other one is C. So once you solve it, you will get 8 factorial dividing by 2 factorial times by 3 factorial, which is equals to 3360. Find the number of different arrangements of the letters, 8 letters in the word, in which first letter is O and the last letter is N. Okay, so you can write first letter as O and last letter as N. How many numbers between them? 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so you can make 8 units between them. 1, 2, 3, 4, 5, 6, 7 will be position that is already occupied by O, and N is the position 8 that is already occupied by the N. So between O and N there are 1, 2, 3, 4, 5, 6. 6 empty spaces. It means that other than one O and one N, you can arrange these letters in these empty spaces. So 6 factorial dividing by the repeating number. O is repeating thrice, out of which one O is already taken. O was 3 times, no? And E was 2 times. So out of 3 O's, you already arranged one O over here that is already fixed. So 2 O's can be arranged over here. So O is repeated twice now, times by E is never restricted, so you can also arrange E in that way. So E will also be treated as 2 factorial. 6 factorial dividing by 2 factorial times by 2 factorial, that will give you 180. So these are different arrangements through which you can arrange them. Okay, next is question number 3, last part. Find the probability that a random chosen arrangement of the 8 letters in the word has 3 O's together, given that 2 C's are next to each other. If you can see, this is a question from conditional probability, because there is a creation of 2 events out of which one is already happened, and you have to find the probability for the other one. So conditional probability suggests that if you have 2 events, so probability of A given B could be written as probability of A intersection B, probability of 2 events to be happens together, dividing by the probability of given event, that is treated as B. So you can treat the event given that 2 C's are together. This is your event B. You have to find the probability that all three O's together. This is treated as A. So event A is basically your all O's together, and event B is your 2 C's next to each other. Okay, so you can find probability one by one. Let me find probability of B first. Probability B is basically the probability of the event when 2 C's are next to each other. When 2 C's are next to each other. So you have to create 8 letter words. So you will create the combinations first, just like 1, 2, 3, 4, 5, 6, 7, 8. When all C's together, it means that here is C, make a box around them. So 1, 2, 3, 4, 5, 6, 7. 7 factorial dividing by the repeating factor is O's. So O is repeating thrice, so 3 factorial. So 7 factorial dividing by 3 factorial, and inside that big box there are 2 C's, so 2 factorial dividing by 2 factorial will never gives you something because they are identical. So इसको आप राइट कर भी लो तो कोई मसला नहीं है, ना भी करो तो कोई इशू नहीं है. 7 factorial dividing by 3 factorial. When all C's together, that will become 840. It means that probability for the B would be 840, right? So at the place of probability of B, I can write 840. Next, I have to find the probability for A and B together. So probability of A and B together. A was all O's together. So it means that all 3 O's together I can construct the equation as here are basically my all O's and two C's are already grouped together. Remaining one would be 3 empty more spaces because I have to take all C's together and all O's together in order to find the intersection. So all O's together, all C's together will become 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 empty spaces. So 5 empty units that would be treated as 5 factorial. No other word is repeated inside 3, 4 and 5 position. No. There may be N, there may be E and there may be T. So these 5 combinations are there through which I can arrange them. So probability of A intersection B would become 5 factorial. That would be treated as 120. So at the position of A intersection B you can write 120. 120 dividing by 840. That will be the answer for that.